Ready. Okay. So we are waiting for people to join now.
I was gonna say, don't everybody jump in at once.
Yep. 2, 3.
I figure it's December. People have to need some HSWs right at the end, right?
Oh yeah, no, folks are coming in, and I just want to say hello to everybody that is coming in, and as they join us, we're going to. I'm going to give it a few minutes for folks to kind of make it into the meeting. I appreciate everyone taking the time out of your busy schedule, or not so busy schedule, wherever you're at this time of year. So we've got Heath on the line, and he is standing by, ready to give us a very exciting presentation. So,
Careful, don't hype me up too much.
I'm trying to talk you up, make me look good.
I don't hype it too much.
All right. Well, let's give it a few more minutes. We've got. So where are you physically located, Heath? Are you in Ohio?
Yeah, I'm actually in the thriving metropolis of Lima, Ohio, which, yeah, so everybody's going to say, where the heck is that? And I'll say it's halfway between Dayton and Toledo, and then still half the people go, where the hell is that? So about 2 hours from Cleveland, about 2 hours from Columbus, and about 2 hours from Cincinnati. So.
Oh, I can do you one better. I used to live in a town in Ohio called Canal Fulton.
Well, you're not far away.
So there you go.
I grew up in
and people go, huh? And I'm just like, Canton, Akron area. Just
yeah, it's
leave it at that.
Yeah, it's Northwest Ohio, and the way I describe it to people is we consider an overpass over the highway an elevation change. So it's that flat.
Oh wow. Hey, I went to school in Ball State in Indiana, so believe me, I know about flat.
You've been through. So, you've been through.
Oh yeah. So it's all going on. So we've got about 7 people that are coming in, and I'm sort of I will start my introduction with the hopes that we get some more folks to join us. So okay. I hope everyone out there is having a really great day. We are going to hear a presentation from our good buddy Heath Warner here. We're going to talk about job site climate control and what it's going to do for us in terms of schedule, safety, savings, and success. Easy for you to say.
I did it on purpose.
I think you did. For over 20 years, Heath has been helping to solve construction-related issues for contractors, architects, and building owners using various materials and supplies for their projects. Now working as a climate control specialist for Chasey Phipps Company, he's advocating to those same parties to work together, take a step back, and look at the entire construction process, avoiding many of those issues through a little more upfront planning. He's a member of the Ohio Concrete and CSI, and he's CDT certified. I will learn to speak. He is CDT certified, which is fabulous. And if you're not, you should definitely consider it because it's a great program. So we are at about 5 after. So Heath, do you want to take it away? And
absolutely.
Oh, one thing. If you have questions that come up during the presentation, please go ahead and put them in the Q&A or in the chat. I will be keeping an eye on both of those, and we will. Heath has said, "Go ahead, interrupt me." We would love this to be more of a conversation than a straight on where he's sitting here telling you information. So let me know what you're thinking, and Heath, take it away.
Thank you, Kathy. And thank you for everybody for being here. And I'll just reiterate that. The only reason I do that is because it's become a passion of mine, and I appreciate honest conversation. I'm only trying to make the industry better. So if you have anything along the way, please feel free to interrupt. So with that in mind, a little bit of background, but first, Kathy and I were talking about 2020 in general, because I thought I was the only one that feels like this is how 2020 has been. And then I keep thinking we're almost to the end of it. And then I remember what the end of that slide looks like. So hopefully we're almost there. But a little bit of background, as Kathy mentioned, about the first 20 years, and it really doesn't matter the names. I prefer to tell people, everybody, my bias up front and where the background came from, so you can see where the information comes from and make your own decisions accordingly. I worked with a lot of general contractors, architects, and actually owners, a lot of subcontractors, restoration, flooring contractors, especially contractors. But what we did was we provided the specialty products end of the equation. In this case, cleaners for restoration buildings, masonry repair materials, bonding agents, toppings from different manufacturers, specialty underlayments, polyfilm cleaners, yada, 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 cures and seals. So a lot of this, which we'll get into in the presentation, a lot of this actually evolved from that kind of a background, because selling these type of products involved with the customer group that I was involved with, I was really only brought in when there was an issue or a problem that needed to be solved. And strangely enough, what we started seeing over and over, almost repeatedly on every job, were a lot of moisture issues with mitigation systems. And one particular job actually ended up with one of those panic calls at 10:30 at night from a contractor that's like, hey, I've got 2 weeks to get this hospital open. I've got a hard deadline to open it. And my flooring contractor is telling me I can't put flooring down. So the moisture level in our concrete is so high, they want $5 a square foot to put a mitigation system down. And he said, you've got to find an alternative. We don't have that money in the budget. If we do that, we're going to lose our butts. So as it turns out, we actually developed a way at the time, because from a product standpoint, we didn't have anything, but we knew there was newer technology out there. It turned out that we didn't get that product or that project because the flooring contractor said that they would not give a warning unless they put a mitigation system down. But what it did do was it started leading to a whole lot of conversations on the why do we keep having this same problem over and over? And we had that discussion with that particular contractor. And at the end of that meeting, that we ended up having several meetings, what we were able to do was isolate a whole lot of problems or issues that were being caused on the front end of the project that ended up having delays on the back end. So then we worked backwards through that problem and started coming up with ways to solve those problems before they occur. And so that's what actually about 5 years ago, we started a climate control division of our company based specifically on solving those problems before they occur. So reality is, I still remember being in the industry almost 25 years now. When I first started, and I don't know how many people are like this or how many climates are like that. You know, Kathy, you work in LA, so heat probably isn't the biggest deal in the world. But in Ohio, when I first started, we would shut jobs down in the winter. It was unbelievable. They would work to a certain point, and when things got too cold, a lot of the larger projects would actually close down for the winter. As time evolves, things get faster and faster. We couldn't do that anymore. So what ended up happening was, well, how do we work all year long? Well, we have all these little portable torpedo heaters. We started slapping those in every one of the buildings. And it made a whole lot of sense because, for number one, low upfront cost. I mean, most contractors in our area of the country, they own several of these things. They're relatively portable, as long as you discount the fact that you need a natural gas supply line or a propane supply line to every one of them. And since they're so common, it just became almost the Kleenex of heating in the winter. But the nice thing was, it allowed projects to continue when they didn't used to be able to. So as time has gone along, newer technology has taken place, but our industry still looks at it and said, well, you know, we've used it for years. We might as well continue to do so. What could possibly be wrong with it if it's cheap, relatively portable, and easy to use? Well, the major problem with that is, and we're seeing a rapid decline of it in our area of the country. Not all areas are, but number one, the issue is carbon monoxide. You've got all of your combustion occurring inside of your work area. which leads to CO and CO2, carbon monoxide and CO2, carbon dioxide levels for your workers. They're ridiculously loud if you've ever heard it. And about once a year in our area of the woods, somebody sets themselves in fire because they're trying to warm themselves up. You have an open flame source inside of your work area. So you have to be very cognitive of your safety plan with chemicals or with anything else that is, not to mention insurance, because you have an open flame source. The other thing, moisture. What a lot of people don't really think about is combustion. Is a byproduct. Combustion is not only carbon monoxide and carbon dioxide, but it's actually moisture. That's a byproduct when you split that molecule apart. In fact, for every million BTU that you have inside of your work area, and typically, just to give everybody an idea for those that aren't familiar, you're looking at somewhere between 30 and 50,000 square foot building. You could push it up to 100,000. You're somewhere between 3 and 5 million BTU, depending on what your goal temperature is going to be. So it would be nothing for a 24-hour cycle on natural gas. That puts about 100 gallons per million BTU, or 100 gallons of moisture inside your work area for a million BTU. So you could have upwards on propane, it's twice that, so about 200 gallons. You easily could be putting 1,000 gallons of moisture into your structure a day, which what happens with all that moisture? It leads to increased finishing times. The picture that you actually see on the left, this is another one of this, and this is kind of where I come in. It's really funny. We actually had the Heath on this project on the front 33,000 square foot. This is the back 100,000 square foot of the building, but we actually did sell the densifier. I got the panic call at 9:30 at night. They had started this pour at 6 a.m. in the morning. At 9 o'clock at night, they were trying to put down the densifier. And what you can actually see in this picture, I tried to get it, that is at 7 a.m. the next morning when I met the contractor on site. In fact, they were having such trouble putting the densifier down, they quit putting the densifier on because there's so much moisture on the surface of the concrete that they just went with cure. You're actually seeing the cure uncured on top of concrete that is now 24 hours old at that point. That particular contractor paid 8 finishers almost 24 hours worth of labor to finish this slab. And when the contractor called me, he says, there's something wrong with that densifier. There's something wrong with that densifier. So I started backing it out and asking what coverage rates were for this particular one. It should have been going down at about 400 to 600 square foot a gallon. They were putting that densifier down at about 2,500 square foot a gallon and still could not get any penetration. The cure that they put on top, they put down at over 3,000 square foot a gallon. And that should be about 300 square foot a gallon. So I told him at the time, I was pretty sure I knew what it was. When we went in there and took RH readings, they were about 87% RH due to all the indirect fire heat that they had. And it just flat out was not allowing the concrete to cure. It was just so moist inside of that structure. So that's one thing. It hurts you on your finishing times. It also hurts you on being able to get your sealers on your floor. Long-term effects of having that much moisture, because if left unchecked, and again, I think other parts of the country are the same way. I remember when polyolefin, and actually, Kathy, the starter of Stego came from your neck of the woods. He was actually an attorney, and
I've met him several times. He's very nice.
It actually very is an incredibly intelligent guy. I mean, who would have thought if you were settling vapor barrier lawsuits that you could get the other side of it too? But the polyolefin vapor barriers make a whole lot of sense because you have all that moisture coming up from down below. But now we've put an impermeable level, so we have moisture trapped from the bottom, and then we go in and I have a contractor, I always joke around, when they trowel a floor, if it's not black because it's that tight, they're not happy. So now we're actually finishing the concrete so tightly, moisture can't escape from the top of the concrete. And then we turn around and put a cure on top of that. Our slabs can't breathe at all. And now we're shocked why we have these moisture problems. To further complicate that issue, we use temporary heat sources that are raising the RH within that structure So now we have high humidity on the outside, we have an impermeable layer below, a relatively impermeable layer on top, and wet always wants to go to dry, but the moisture has nowhere to escape. And even if it could escape, it doesn't want to go because the RH level of the air is so high that it doesn't dry out. So we've used in the industry for years, 30 days per inch is what it takes for hydration. I tell everybody at this point, with the polyolefins down below and then the cures on top, it's almost 3 times that for most mixes. So then we're shocked when we get, 6 months down the line, we're trying to put flooring and we have a moisture meter that's reading 99% RH, and we have to put a mitigation system down. Not to mention all of that moisture increases your chances for mold and mildew and sick building syndrome, other things. The other issue with having all of your combustion inside your slab, inside of your building, is carbonation. This is actually, excuse me, this is actually another project. We had bid the heat out on this job, and I got a call from the contractor, and I don't know how well it shows up, but he says there's a problem with your cure. We're getting white dusting all over our concrete on our first pour. This was within the first week. And what was interesting, when we went out there, I was able to walk, and you can almost see it from this angle. It actually gets darker the further back that you go, but the further you get towards the front, really starting in about here, and especially down in this area, you can actually see the carbonation. Where you sit looking at your chair, looking at this picture, right in this area was right where the open flame heater was positioned, and it was blowing clear across the slab, and it was actually leaving such much carbon residue that as the structure or the floor was being poured and finished, they were actually working the carbon in, and it got less as it went down along. When I pointed this out to the contractor, and their concrete foreman looked right at him and goes, yeah, he's right. Yeah, the guy walked right over, unplugged his heater, and said, get your stuff out of here, or get over here for the other 80,000 square foot. We can't afford this. And thinking back from the material perspective, again, why I kind of gave you that up front, I cannot begin, and I'm ashamed to even tell this story, how many times and how many projects I was called out to in the springtime because we need a sealer because our floor is just dusting. We're having issues with all the equipment's getting dirty and it's just dusting. At the time, I had no concept or clue. Everybody thought that it was just a little problem with the weakened surface of the top of the concrete. But in most instances, it can be traced back to the carbon sitting there causing contamination being put onto the surface of the concrete, and it weakens it enough through carbonation that they have a weak surface that does. So with knowing that that's probably the most common use, what has really changed in our world? And this is where things have really changed more in Ohio, but honestly as an industry. For us in Ohio, it really started out with the EPA reg changes of 2009. They kind of really took force for us before the big LEED and green movement, but they were an impetus ahead of that. What really changed in our industry as far as the product goes was that 250 grams per liter. Or 350 grams per liter, excuse me. Once we had that magic number, all of our xylene-based products went away. So a lot of manufacturers struggled to get down below that magic number. A lot of them played around with different acetone-based or proprietary. There's one manufacturer that used what they called a T-back solution. What it really meant for the most part was a lot of the products that we use in the industry were going to have to go water-based if we were going to use them. And one of the biggest are, we talked about carpet tile, big squares before the meeting. Carpet adhesive is actually one of the worst in VCT adhesive, because when they put that stuff down in a water-based, it's great as long as moisture doesn't get back to it. And going back to that example of that perforated polyolefin barrier, that's part of how the polyolefins were sold originally. A 3/8 inch hole in your vapor barrier, by the time a drop of moisture migrates up through 4 inches of concrete, it becomes about a 12-inch circle in studies, which is almost the same size as your common VCT tile. The sealer that we use that's water-based they're not water, since they're water-based, they're water soluble. A lot of times they'll revert back and they become a petri dish for mold growth, not to mention they lose adhesion. So there's a whole lot of problems with using those, which leads to moisture issues. And like I mentioned before, all the other problems with having moisture in that slab are now magnified because we have products going on top that can't handle what we used to just put solvent-based sealers on to hold the moisture down. One of the other things that really changed are the new silicosis regulations. The exposure that is allowed on most job sites for permanent tracking of the quality of the air has to be a plan, and it has to be in place. Not to mention the OSHA regulations, and they're pretty much standard by state. But that 50 parts per million, a little known, if you are in a highly safety conscious environment, it is actually very surprising if you're using an open flame source for your heat, that 50 parts per million is actually really hard to achieve. In fact, it's so difficult. If you're in an area that's highly monitored, they'll actually end up pumping in outside air to lower that parts per million just from combustion, which is really kind of disingenuous to me, because if we're heating up the air because it's too cold to continue to work, but then we have to bring cold air in to overcome what we did to heat, then we have to heat in the cold air that we brought. Oh yeah, it becomes a chasing your tail loop to try to keep workers safe. And it goes so far as to, I've had contractors tell me when I could show them, levels of safety. Yeah, we know. Sometimes we have to unplug our monitors, and it's just not safe. Having open flame combustion inside your work area when technology exists to not to, it's not going to be able to continue. In fact, again, Kathy, you mentioned how close you are to Canada. You can't use an open flame source in Canada. It will be interesting to see where we go in the future, but I think that is probably coming. So it would be really bad if I sat here and I told you, yeah, everything we do in the construction industry is bad and there's no alternative. That's actually where hydronic climate control comes in. And again, I mentioned Canada. This technology actually was developed in Canada. The really astute viewer will say, hey, that looks a lot like a ground thaw unit. And I will say, absolutely, it was developed from a ground thaw unit. The basic technology itself has been around for about 30 years. And what we're doing is, you can actually see, this is the heating unit that sits outside of the work area. And these are the exchangers that sit inside the work area. So the technology that's been around for about 30 years has really been perfected to the point where it's small and portable enough to actually be realistically used on the job, and inexpensive enough to be rented. But really what's going on is that heating unit that sits outside, we're flash heating food grade glycol up to about 180 degrees. The glycol is actually USDA approved for direct food contact. It's the same glycol. It's a polypropylene glycol that's used in cosmetics, hand gel, hand sanitizer, shampoos. That's how safe the system is. That's being pumped through 300 PSI hoses at only 30 PSI. And the reason that that's important, at 300 PSI, they're very hard to puncture and they're incredibly safe. Into the work area, where those little electric exchangers that are about the size of a dorm room mini fridge expend the air out, the air is sucked back in, the glycol returns to be reheated. So it's an enclosed system. What's really cool is external combustion. A lot of people think of external combustion as adding cost because you're heating outside air. They directly go to what had been the solution to a lot of the problems we talked about earlier with direct fire. We moved the flames to the outside and we pumped the hot air in. Well, indirect is actually totally different. It is a torpedo heater and it is dumping hot air in, but there's no recirculation, and you always have to overcome ambient. No matter what ambient conditions are outside, that has to be overcome. So generally the rule of thumb is about 1/3 of every BTU is thrown away just to overcome ambient. And once the air is dumped inside, it needs a network of fans to actually blow it around. It's not uncommon, and we've had a customer that used it, and they said that the room that they have indirect fire dumped into, it's usually between 100 and 120 degrees, unless they can get it pushed back. And there's always cold spots in the back that could be 20 degrees off because you're just creating heat and dumping them in. That's actually what sets hydronics apart. So we move the combustion outside, but in reality, the burners that are actually in there, and you can actually see one right here, that's an Italian Riello burner. And the reason that we use Riello is they're about the most efficient burner on the market. And the reason that I bring up Riello burner is because as spec writers, there's probably a lot of you know, that's actually a permanent install industrial burner. Our system uses the exact same burner that a permanent HVAC system would use. So with that flash heating glycol up to about 180 degrees and then moving into the work area, we're typically returning that glycol at about 150 degrees. There's usually a 30-degree temperature differential. Each one of those exchangers that sits inside the work area blowing that hot air is thermostatically controlled. So you can actually set zones within a building. But the real beauty of it is, since they're constantly sucking and blowing air in, recirculating the air within the structure, this unit actually gets to cycle as long as the temperature differentiation is 30 degrees. It's literally like your home furnace at that point. It operates about 1/6 to 1/8 of the time, as opposed to a direct fired heater or an indirect fired heater that have to operate at 24 hours a day, 7 days a week, and they're not producing any heat, not to mention overcoming ambient conditions. So right off of the bat, you're able to cut your fuel expense during construction by about 1/6. So the system really pays for itself. And why I mentioned the technology's been about around 30 years, just like the phones that we have and the computer, the laptops that are in front of us. The technologies continue to evolve. About 17 years ago, I actually turned the first company that brought the technology down to us, because we had to have, at the time, they were 2-inch hoses. So a 50-foot hose weighed 150 pounds. You had to take a manifold the size of a table into a room. You had ball valve couplings. Everything was ungainly. But really the problem was the cost. The cost was so expensive, it really didn't make a whole lot of sense. But as things evolve and things come along, the cost right now is so effective that most jobs can factor it in, even if the owner's paying for fuel. If you factor the fuel into it, the owner actually saves money, and everybody saves money from the environment that comes in. The other benefit of that recirculating air, and I don't know how well this comes across, but this is a 22,500 square foot, 2-story hospital. All of these pictures were taken within 20 minutes of each other. And the picture that you saw earlier, this is the center of this, and actually I'll even go back here just so you can see it. This is actually the hospital that you're looking at. Oh, I didn't think it was that far back, my apologies. This one. All of the heaters that we're going to talk about, the exchangers, are sitting right inside of this area. So these pictures are from the upstairs, the downstairs, and various points around that building at the time. Almost. And what you're looking at with all those exchangers dead set of the building, 68.9 degrees. This one's 69 degrees, 68.7 degrees. This one actually is 70 degrees. It's incredibly even. If you can keep the structure tight, you're looking at less than 2.5 degrees difference variation on this project anywhere in the building. And it's chopped up medical exam room, patient exam rooms, just offices galore. So it's just incredibly even. We did a project, 125,000 square foot wide open warehouse. They had everything in the far north corner. And once the unit was operating, it was less than 1.5 degrees different anywhere in that building. But along with that, since you're not entering any combustion or moisture inside, the hydronic system actually, if you have a really touchy meter, it's about 5 to 7% RH. So for about every 10 degrees over ambient, you're actually going to cut the humidity in the structure in half. So instead of adding moisture to the structure, what you're actually doing is operating at 26.8, 29%, 29.3, 25% while they're spreading insulation. So instead of having moisture issues, you're actually solving moisture issues. You're drying your slab out, you're drying your drywall out. In fact, we had a project and I walked up to a subcontractor and he stopped me to thank me for what was going on. And I said, well, why? And he says, I don't think you understand. He said, you know, we hung drywall today. We mudded drywall today. My guys are back there sanding it now. We've never done that in a project in Ohio in January before. He says, furthermore, he says, I don't have to worry about coming back for shrinkage cracks because I know the mud was cured the correct way. So it helps all phases of the construction cycle as the building goes along. And I don't know how much, if you really want to go into this, but there are varying unit sizes. There's actually 6 of them. I affectionately just call them small, medium, and large. So you can match about any size job. The small one, under the ideal conditions, will be about roughly equivalent to, and this unit is the small one, and it's about 4 by 6 to give you an idea, 4 foot wide and 6 foot long. That's how small it is. This is actually a AAA auto center that they didn't have permanent power, so they ran this thing on a little Honda Harmony. Very effective as far as fuel goes. They're tri-fuel capable and they can be sized for any job. The other beauty of these type of systems, not only outside but inside, are the exchangers. Because I don't know when the last time you were on a project that had enough power, but typically power is an incredible commodity on projects anymore. And the small exchangers only need about 1.8 amps. The medium exchangers are 5.8. Even the large exchanger only needs 120 volt, 20 amp circuit. So they'll fit into just about any heating plan very easily without modification or extra cost. So going back to LEED and indoor air quality, and this is a point where I don't think enough people take advantage of, but I'm wondering with the COVID situation if that doesn't develop further. But because you're recirculating the same air, you're actually looking at the only temporary heating source on the market that is actually fully MERV filterable. You can put any MERV filter onto this, and I jokingly, this slide is actually in here because I had a contractor tell me one time, oh, job sites aren't dirty, at least not in the winter. This is a filter that is so clogged up that it crushed itself in and tried to suck itself into oblivion inside the unit. Job sites are dirty by nature. And when you're using a permanent system, that's going into your permanent system. These filters are actually at least easy to change. But furthermore, and a little bit more timely, we talk about filtration for virins, because when's the last time that you were on a job site where 6 foot could be maintained the entire time and proper social distancing and this, that, and the other? The University of Minnesota actually did a research study where they tested silver particles that were 5 to 30 times smaller than the coronavirus. And to give you an idea, oops, sorry. This is actually your typical dust molecule size. And this is actually the coronavirus size. So a typical MERV filter is probably going to catch, depending on the MERV filter, 50% of that. And most of our permanent systems only catch about 50% of the particulate. Whereas this is HEPA filters, actually 99.99%. HEPA filters are incredibly effective at filtering out. And one of the nice things is, since the hydronic unit is actually MERV filterable, they can actually be converted and become HEPA filter machines too. So you can have incredibly safe environments for your workers and final occupants of the building. It's actually one of the other big benefits of hydronics that can actually fit into emergency heating situations and temporary heating situations because of how safe they are. Just how safe are they? Those exchangers are fully UL and ETL certified, so they can go places that most people or heating sources can't go. This happens to be a refinery in the Toledo area. The mechanical contractor had to do epoxy grout in the dead of freaking winter. And in order to get, if you've ever done epoxy grout, when it gets to below 30 degrees, actually below 50 degrees, you can't get it to flow at all. So they had these little pop-up tents that they had to heat and keep at above 70 degrees in order to do this epoxy. And on a 35 degree day, you can see it was at 74.8% inside of this 2,500 square foot heater. The reason I mention all of that was it was actually the first time, and this goes for local fire departments too, usually when we submit this information, because your heating or your ignition source is fully enclosed, because everything is UL and ETL certified, the technology is actually so safe that the refinery actually approved and let the contractor out of the 24-hour fire watch clause. And when we left the meeting, the contractor says, "Do you know how much money you just saved me?" I said, "Pretty cool, huh?" And he actually ended up using us on 6 more of these projects across 3 different states that year alone, just because of that, how safe it is. So because there's no emissions, confined space. Yes, ma'am.
I have a question.
Absolutely.
On the unit where you have the tubes running around to the job site, is there ever a tripping problem, or do you have a problem with those tubes getting in the way?
Nope. Actually, we're going to get to that. There's a slide right ahead. In fact, let's just skip ahead 1 slide, shall we? Okay. Nice setup. Thank you. So if there's a safety concern at all, we can actually, a contractor can actually hang this. The picture on the left is actually a hospital in Toledo. It was a 40,000 square foot addition. It was almost like a V added on to the existing surgical center. And what they ended up doing was they suspended the hoses right above head from the ceiling, so they put the exchangers in the middle. The middle picture is actually a hotel that was built in Findlay, Ohio. And they actually chose to suspend the exchangers on the wall or along the wall and just hang the hoses that way. But here's the funny thing, and I mentioned that 125,000 square foot area. I tell everybody, if it's an option, and it's especially an option if you've got a big wide open area, but really it works in about every job. Because the unit just constantly recirculates the same air, as long as you can keep the structure relatively tight, unlike any other heat source, placement of the exchanger really isn't that critical. As long as you can get the heat inside the building and maintain proper circulation, you don't need additional fans. You can just put exchangers along wall lines where they're not in your way. You can see this one actually has the hose right along the wall line. That was about a 65,000 square foot senior center. So it did have a wide open area. But so the beauty of that is it recirculates the air. It's never in your way. You can actually go up the side of walls, and on the outside, that's probably what we like to do the most, is just keep everything outside the structure. But it's incredibly safe. So there really isn't a concern about trip hazard that you can't overcome by just being a little bit more creative with where you place the exchangers. Does that answer your question?
Yes.
Awesome. So when you talk about safety and hoses, this is really where things started to clicking for me. When you start thinking about open flames in heat sources where you can't have it traditionally, this is actually EFIS work. This kind of gets you an idea scale on what the smaller machine would be. But you can start doing EFIS cornice work. You can start doing pinpoint masonry work. This is actually masonry work that they were doing on the entire backside of this hospital in the dead of winter. And I jokingly tell everybody else, I said, if you can find any other heating source where you can actually place it right inside a climber scaffolding unit, and the hose is actually running right here, and it's safe enough that it can sit right next to your guy, I would love to see it. That's how safe it is. The other beauty of it is, since you're not adding a bunch of moisture, when you start talking about wood structures, like this is a residential area in downtown Cleveland, you don't have to worry about pumping a lot of moisture in and then your wood shrinking and drying and warping later on, because you're maintaining a consistent level of humidity through the entire project. Not to mention, since you're not putting carbonation in, you don't have to worry about slab contamination. And this kind of answers your question too, Kathy. When we first set up this job, it was 150,000 square foot area. They didn't even have walls. Everything was temp plastic in. This was actually this 35,000 square foot area. That was the only section of the building they had a roof on. So in order to keep heat in, since they had no R value in the walls and only had some in the area, and they wanted to pour the entire floor, they actually suspended the exchangers right overhead so they could pour the slab. Then later on, as they continued pouring the rest of the building out, they had little outcries and pads that they could stop and put the exchangers out of their way as they build around them. This slide's in here because it's actually humorous. That's a flammable epoxy, and I don't necessarily advocate that, but that's how safe it is. You don't have to worry about an ignition source next to your ignitable material. But really, the funny thing is, for anybody that's been involved in if you've ever been involved in traditional open flame heating at all, epoxy is very susceptible to UV yellowing. So are urethane caulkings, and I could go into a whole bunch of stories of that. But I gave this presentation at a actual manufacturer of floor sealers, and I had one of their chemists come up afterwards laughing. And he said, that slide that you had in there about fisheye yellow epoxy. I said, yeah. He says, if you ever need a reference, send them my way. He said, we had a job about 20 years ago. He said, it was a huge job and the whole thing turned yellow. He said, we could not figure it out. We had 7 or 8 of our people looking at it and working on it. He said, finally, after months of being frustrated, we had to pay to have the whole thing redone. He said, I started looking at our competition's data sheets. He said, I started seeing no open flame source, no open flame heaters, no torpedo heaters. He said, we started doing testing. It's in our data sheets now too. So those type of materials that are susceptible to UV yellowing and fisheyeing, you have to be really cautious of the kind of heat that you're using. The other thing that we don't think about is, you talk about susceptibility, just how susceptible some people are. I was actually out with the owner of our company one day on a job site, and we had a laborer come up to us and he stuck his hand out to shake it. He said, thank you. And I said, for what? And I know this sounds like a bull crap story, but it's absolutely true. I said, thank you for what? And he said, I just want to let you know. He said, 37 years in the trade. He said, this is the first job I go home at night without headaches. I said, oh my gosh, you don't stop and think about what those CO2 levels do to people that are, susceptible to them. So hydronic jobs by nature, because they're so safe, they almost become default break rooms. You got microwaves here. This guy's lunch is really sitting here. You can see the entire area turned into a makeshift rest area. That's just how safe it is. Jump ahead. So that kind of covers up how you can avoid a lot of the problems as far as what's created in the winter from a climate controls perspective. And the reality is, not all of you guys have climates like us that are 6 months cold or 8 months cold. So there are other areas and other, let's see how we're doing on time. Okay. We'll buzz through this a little.
You got about 10 more minutes.
Yeah, we'll buzz through this a little bit faster, but feel free to stop me if there's more questions. But just because winter's over doesn't mean there aren't issues. Moisture issues on jobs are a problem no matter what. This particular job site was actually a 3-story medical area, or it was actually going to be a senior living center. And you're looking at 78.4% on the middle floor. They actually had roof leak problems and they had snow problems on the first floor. But we in the construction industry, going back to being stubborn, do some things that are questionable at times. This much moisture on a job site, you're being sealed in with your insulation. We're looking for mold issues. Anytime you've got 78% RH, you're going to have problems. And mold mitigation is ridiculously expensive. And most of the time, this can be taken care of, number one, sealing up your leaks, but having some kind of a plan. talking about plans. This was actually a 250,000 square foot school in Northwest Ohio that when we first showed up was running 90 to 98% RH. They actually were they had planned to have their permanent HVAC system on, and as it happens a lot in our industry, the permanent system ended up 3 to 4 months behind. And what they found out was a permanent system is not designed for a temporary basis, and it couldn't keep up anyway. So they needed an immediate plan, or they were gonna lose about 6 months of shutting down this job. So what we ended up doing was putting a whole bunch of dehumidifiers spread out, because we had to work within their electric plan. But you can get things in control. There really isn't a point. That's the beauty of portable equipment, is you can match the solution to the application. And humidity control and temperature control is a discussion that comes up all the time. A lot of times people just want to throw air conditioning on something. And I tell everybody the same thing. When you go back and you look at, it's not just for comfort. You have to start looking at dry times of drywall mud, dry times of finishing compound, drywall times of paint. This slide actually shows the difference. It's 1/16 inch, and probably a lot of people are familiar with it, but the difference for 1/16 of an inch of drywall compound, when you're looking at an RH of, it doesn't even matter, let's just pick 70 degrees. You have a compound at an RH at 50% dries in about 17 to 19 hours, which is great. It's 1 day cycle. If you raise that up to 80 to 90% RH, you start talking days instead of hours. So you are losing a ton of time or we are losing a ton of time in our schedules just due to not controlling climate conditions on job sites. Furthermore, again, back to our flooring discussion, a lot of people don't realize that if you have a very industrious flooring subcontractor, every manufacturer has some kind of a restriction in their terms and condition for their warranty. And every one of them has some level of temperature and, more importantly, humidity. And when you start looking at how restrictive they are, brand A flooring company, 35 to 55% RH, that's for installation and for the entire service life of the job. There are literally jobs, brand M is actually a lot more forgiving at 20 to 80%, but 65 degrees to 85 degrees, 40 to 60% RH, there's a lot of job sites that are just not maintaining minimum standards. And again, a lot of it goes back to, it's not just a warranty concern, it's the adhesive concern, growing mold, petri dishes, overall issues that we're going to experience just from not controlling conditions. I'll buzz through this, but this is the discussion about air conditioning versus temporary dehumidification, because a lot of people think that air conditioning is the answer. Air conditioners are very inefficient dehumidifiers. Realistically, you need about 6 times as much equipment to do air conditioning. You need a lot more power. It's a lot more costly to do it, and it removes a lot less moisture. The reason I do bring up temporary air conditioning is for our industry, flooring concerns, but even worker safety. And this is really what scares me. And before the whole COVID thing, I used to call this the tinfoil hat part of my presentation. But I really think you're going to see temperature restrictions coming to our industry at some point. Back in July 17th in 2018, there was an advocacy group of 130 different union contractors that actually submitted against OSHA wanting restrictions against temperature. In an interview with David Michaels, who headed OSHA at the time, he was asked why in the world that they didn't go after worker safety more. And his response was actually, they were too busy working on the beryllium and silica dust regulations that I mentioned first, and then they fully intended to go after temperature restrictions. So I'm of the opinion that it's not a matter of if, it's going to be a matter of when we have some kind of standardized working conditions in our industry, whether that's on the low end for heat or the high end for air conditioning. In the future, the climate for our workers in general is going to become more of a hot button. So stay tuned for that. Large scale dehumidification. I mentioned earlier in the presentation, as far as hydronics go, dollar for dollar, it is the least expensive form of dehumidification. You can actually, since for every 10 degrees above ambient you actually cut the humidity and structure in half. So you're able to do large volume for a lot lower dollars. In extreme cases, the beauty of doing this, you can actually pressurize a structure. And instead of removing, the best dehumidifiers on the market will remove about 25 to 30 gallons a day per 24-hour cycle out of a building. With hydronics, you can actually pull 25 to 30 gallons out of a building and dry something out in a matter of hours. The funny thing is the insurance companies fight this technology because it's so hard to figure out how to get paid, because they get paid per piece of equipment. Whereas if you were doing hydronics, you could cut the drying times for most projects from weeks to days. So it's incredibly effective. Large sub-base concrete pours, this picture was actually the same structure taken facing different ways. That was 5 days apart to dry out that slab with hydronic, or dry out that sub-base with hydronics. This was actually a maintenance facility for ODOT, and you can kind of see when they opened up the metal panel, they had sandwiched insulation in between the metal roof panel and then the metal liner panel. And for whatever reason, there was not enough airflow, and the insulation wasn't compressed enough. They were getting condensation. And I have videos of 55-gallon drums worth of water just being filled when we opened up this roof. And what we ended up doing, or the contractor ended up doing, was they removed panels. And if you go in and remove more, it was mostly isolated to the main area, but you probably could have dried it out faster. But they opened up enough panels that they were able to dry out and save almost all the insulation within 2 weeks. Same thing goes for high RH levels within floors. And I don't know how well this is going to come across, but I left the one where it actually has a crack so you could actually see the difference. This is actually 99% RH. We installed that on a Friday, and the following Monday, it was actually down to 87% RH, or 81%, I'm sorry, because the rubber flooring that they needed to put on this floor actually had to be below 85%. So they were able to save $3 a square foot on a mitigation system by using hydronics to dry the floor. Doesn't necessarily work in all applications, because like I said, if you get the floor really tight and you've got a sealer on top of the floor, it's like trying to suck that water out of a straw. So it could take longer. It may not be effective at all. It's kind of a case-by-case basis, but it is a lot less expensive way to accomplish a goal. Last thing that I'll just mention, we touched on HEPA a little bit ago. Excuse me. I'm not sure, the reason I throw this in there is because you talk about technology developing. This is actually the Toledo Museum of Art. Millions of dollars worth of artwork around this renovation area, and they absolutely could not have any dust getting out, but they couldn't even have fumes getting out of the area. And of course, in construction, we've got a lot of chemical smells. You can actually put carbon pre-filters into your HEPA filters and other type of filter machines, and you can filter out 99.9% of the solvent smells as well. So there is, as far as whether it's airborne contaminants, dust particulate, or odor particulate, or CO2 levels, or even virus concerns, there is a filter that is out there that can help most job sites. It's just a matter of researching it and figuring out how to keep your job going. And that's really kind of I know I sped through the end on that, but my take on that is, and we talked about this before, I love this industry. We're just very slow to change and embrace new things. The technology is available to help everyone at every level, from the owner all the way down to the laborer. You just have to have a plan for your job site and take advantage of it. And then everybody benefits and saves money in the end. So that's kind of it. Thanks for the time. If there's any questions, let me know.
Very nice. Thank you very much, Heath. And if anyone has any questions for Heath that we didn't get to during the presentation, you have an email address to say, there we go. Here's Heath's contact information, and he will get back to you. So
Absolutely.
this was actually very interesting. I really wish some of my concrete friends could have been on the call and heard some of this stuff. So in the meanwhile, we are getting close to our end time, and I wanted to just tell everybody that we have coming up on January 7th, we have our next presentation is going to be thermal breaks in cladding support attachment assemblies, which is a mouthful. But basically, we're going to identify and compare various cladding attachment methods and determine what's the most appropriate and how to get thermal breakage from that clip and within your system to get the right thermal resistance that you need for your project. So that should be very interesting. Northern Facade is going to talk to us in January, which seems appropriate. In the meanwhile, Heath, thank you very much. Everyone, be sure and answer the survey that's going to come up so that you get your credit for attending the webinar and you get your hours and stuff. It was great information, much appreciated. So make sure you take down Heath's contact information, and we'll see you all in January. I hope everybody has a great set of holidays and relax, stay safe, stay healthy, and stay happy. So bye, everybody.
Again, everybody.
Bye, Heath. Thank you very much.
Thank you.
Merry Christmas.
Bye-bye.
Bye. All right.